again, a little device as big as my finger with important do not remove on it, and it's taking out the industrial control system. Hello and welcome to Waterfall's Industrial Security Institute. I'm Andrew Ginter with Waterfall Security Solutions. In this series of videos, we're working our way through the top 20 cyber attacks on industrial control systems. We're using the top 20 attacks as a ruler, as a measuring stick, as a way of comparing the strength of two security postures at a hypothetical target, a water treatment plant. Our first security posture that we're evaluating is 2013 classic advice that, all of the standards and best practices back then were advising us, use software protection, use antivirus, use security updates, use encryption, use firewalls, do intrusion detection. The second security posture is that same 2013 vintage security system with one change, an addition of a more modern piece of advice, which is replace the IT/OT firewall with a unidirectional security gateway. The gateway is one device, and it's now the only interface between the industrial network and the IT network. Today's attack scenario is number 15, a compromised remote site, sometimes called a leave-behind attack. How does it work? Well, this is a water treatment plant, and if you remember our very first episode, we went through all of the bits and pieces of the industrial network architecture. It included a wide area network component that connects the SCADA system in the water treatment plant to pumping stations all over the watershed, all over the city. These pumping stations are, physical installations. These pumps can be very large, they can be a little bit smaller. They generally are a piece of land with a fence around it. The fence is locked. There's a pump there. It might be inside a building, it might be outside, but there tends to be a little shelter there for the control equipment, for a PLC, for an RTU, a computer that is controlling and monitoring the pump and maybe a reservoir and maybe some pipes and pressures and so on. In this attack scenario, our attacker is a hacktivist. This is someone who has it in for the water treatment plant, or for the city for that matter. They've decided they have some grievance that they want to pursue cyber-wise, and they do this by getting out their lock cutters and physically cutting the lock and walking into the little control shed that controls the pump. They do this in the dead of night so that they're not caught, and what they do is they tape a small laptop underneath a computer in, let's say, the rack that's in there that's holding all the computers in place. They tape the laptop into an unobtrusive place underneath something else where nobody can see it, and they leave. Now, having broken into this site, it's going to be detected. It might be detected reasonably right away with alarm systems. It might be detected down the road the next time a technician visits the site and says, hey, the lock's been cut. What's going on here? An investigation ensues. People come in and they look, and to their surprise, nothing's been stolen. Everyone expects something to be stolen or damaged when someone breaks into one of these sites. They don't find anything. Nothing's been stolen. Everything that's supposed to be here is still here. They don't notice the extra laptop. It's a leave-behind attack. They're not taking anything away. They're leaving something behind. The laptop is not just a laptop sitting there. The laptop has been connected into the little network in the pumping station with a network cable, and the laptop has been left running, has Wi-Fi, plugged in, power. Nobody notices an extra power connector, especially not if you put a bright red sticker on it that says important, do not remove. Nobody will ever touch that. When everything settles down, a month and a half later, the attacker comes back in a van or a car and parks some distance away from the pumping station and connects to the laptop over the laptop's Wi-Fi. What does the attacker do? They look around the pumping station. They use standard attack tools. They'll download Metasploit. It's their laptop. They can download whatever they want. They'll use free attack tools they've downloaded from the internet. They'll find their way around. They'll find the connection to the wide area network out to the SCADA system, the industrial system in the water treatment plant, and they find a way to attack that system. They get into the water treatment plant. They might have stolen credentials. They might have found some kind of control connection that is not authenticated, that doesn't have a password. There's a lot of these in these older control systems. And they pull off a Ukraine-style attack. This was the attack where they told the HMI, hey, go into training mode. The operator is the teacher. I'm the student. Show me what's happening. and they can see the screens that the operator is going through. They can come to understand how the water treatment system works. And when they attack, they flip the bit and they say, we're still in training mode, but now I'm the teacher, you're the student. And they start operating the screens and cause the water treatment system, most likely to shut down. Or they plant ransomware or something. They do something bad. In terms of sophistication, these people have a degree of cyber sophistication. They understand how these attacks work. They've used these tools before. They are not professionals in the sense that they don't make a living attacking water treatment plants. They don't have a lot of money they can spend, but they can download stuff and use this. It's a moderate cyber sophistication attack, and the engineering sophistication, is low to moderate. It starts out low. They don't know how these systems work, and they watch the screens and they learn as they go, and they develop a degree of engineering sophistication. In terms of consequences, well, the plant's going to shut down. That's almost inevitable. And when plants shut down, there might be equipment damage with the emergency shutdown. There might be hard drives erased. This is typical. There's going to be some cost to clean it up. There might be some cost to repair equipment. So it's low to moderate consequences as well. The attacker has not used software vulnerabilities to get into the system. So the security updates really didn't save us. This was a physical attack. It was not a cyber intrusion. It was a physical intrusion with cyber consequences. The intrusion detection systems might catch this attack if they see something in the substation reaching out to the SCADA system at the water treatment plant. Usually the SCADA system reaches out to the substation. But if there's technicians in the substation, if there's work being done in the substation, yeah, people in the substation the technicians might connect their laptops to the substation network. They might connect back to the SCADA system. So if these attackers go low and slow, if they're not greedy and, attack everything simultaneously to find out what's going on, if they just take one step at a time, you're not going to see a lot of suspicious activity if they take long enough, which means they might get detected. They might pull it off. And so the 2013 vintage security posture does not reliably defeat this class of adversary. Unidirectional gateways deployed at the IT-OT interface. This attack didn't go through the IT-OT interface. That gateway is irrelevant to this attack. The rest of the security system is the same as the 2013 attack. And so again, this security posture does not reliably defeat this class of attack. Now, if you've been tracking the white paper that I published, you'll have noticed by now that some of these scenarios I've simplified a bit, and they're not quite the same as the scenarios in the white paper. In particular, I have simplified the two defensive postures so that it's easier to see the difference between them. In the white paper, I've described a more complex unidirectional defensive posture where unidirectional gateways are deployed at the interface to the pumping network as well. And so this is why you'll see some differences in my conclusions. I've tried to simplify it here for the sake of the videos. If you'd like to see a more sophisticated unidirectional security posture, it's in the white paper. I'm often asked with these attack scenarios if we have observed this attack in the wild ever. And for this one, I have to say no, we've not observed this one in the wild. What we have observed over and over again is this class of attack on IT networks, against IT networks, leave behind attacks. So that something, someone visits a site that has access, to the IT network, plugs something into the wall and leaves. A little Raspberry Pi device that looks like, I don't know, a wireless access point or a charger or something like this. So these class of attacks have been described a lot in real life and in theory. I saw a very scary presentation from Canada Public Safety a couple of years ago where they went through a dozen of these leave-behind attacks that were just nasty. Again, a little device as big as my finger with important "do not remove" on it, and it's taking out the industrial control system. So, no, we've not observed these in the wild in industrial targets, but they certainly have been discovered many times on IT targets. So that's what I had for you in this scenario. Don't forget to download the white paper if you're interested. There's a link below the video, every place the video should be posted. And you watched to the end of the video. Thank you. do us a favor, give us a like and subscribe. Thanks again. We'll catch you next time.